So here we see the same example that we have before, and there's also the equation on the left to solve for it. So here we have our Ba2 plus, and the first thing I'm going to do is clear the values. And after we've cleared the values, we're going to use our time value of money functions on our calculator. So the first thing I'm going to do is hit second and FV, and that's going to clear our time value of money worksheet. In this case, I'm calculating in, so I don't need to put a value in for it. Our I, or our interest rate in this case, is 5.5%, so I'm going to hit 5.5 and then IY. Our PV, our present value, is going to be $100. And we can think of it as a negative amount because we saved that amount. So I'm going to type in $100 and then hit our plus minus key. And then hit PV. Our payment is 0 because there is not an annuity associated with this problem. So I'll type in 0 PMT. Our future value is going to be $200, or in this case, twice as much as we had before. So I'm going to type in 200 and then hit FV. And now we have all of our inputs, so I can simply solve for n. So I'm going to hit CPT and n. And here you'll notice that we get an n of 12.946157, the same amount of time we did with our formula. In this case, if we assume that it earned 5.5% per year, it would take 12.946 years to double. So here we see our next example. Assume you invested $1,000 and your investments are now worth $3,750. If you earned an annual rate of 8.5% and you had quarterly compounding, how many years were you invested? So in this example, it's important that we distinguish between the number of years and the number of quarters. Just like with our formula, we had to make an adjustment for quarterly, and we'll do that with our calculator as well. Here you see the formula from before. And now we'll use our financial calculator. So anytime I begin any time value of money calculations, I always clear the time value of money worksheet by hitting second FV. And we're solving for n, so we'll skip over that one. Our IY is going to be 8.5% divided by 4. So I'm going to type in 8.5 divided by 4 equals, and then IY. Again, it's important to hit equals here. If not, it will store the 4 instead of the number we want it to store. Our present value in this case is $1,000, and we saved that or invested that, so it came out of our wallet, so we would use a negative amount here. So I'm going to type in 1,000, then hit our plus minus key, and then PV. Our payment is 0 because there is not an annuity associated with this problem. So I'll type in 0 PMT. And then our FV, or our future value, is going to be $3,750. So I'll type in 3750 and then hit FV. Now we can solve for our n. And it's important to remember that we've made an adjustment for our interest rate by dividing by 4. In other words, when we inputted this into our calculator, we already accounted for our quarterly compounding. So that n that comes up will be the number of quarters. It will not be the number of years, it will be the number of quarters. So I'll hit CPT and N. And you'll notice that it has 62.858837. Again, that is not the number of years, that is the number of quarters. Because we made an adjustment to our interest rate, we have to make the same adjustment to our N. And so in this case, we need to divide by 4. So I'm going to hit divide, and then 4, and then equals, and that tells us that we had this investment for 15.7147 years. So again, just like with our formulas, the important part of these equations is to make sure that we properly adjust for any compounding frequency presented in the problem.